morning students, welcome back to online classes once again. Students, already I have taught you properties of whole number for addition and subtraction. Today I will teach you properties of whole number for multiplication. There are several properties for multiplication. First, closure property. Second, commutative property. Third, associative property. Fourth, distributive property. Fifth, existence of identity. Sixth, multiplicative inverse. And last, seventh, cancellation law of multiplication. Now, I will explain you the first property, closure property. If x and y are two whole numbers, then x into y is also a whole number. For example, if x is equal to 5 and y is equal to 8, then x into y is equal to 5 into 8 is equal to 40. And we know that 40 is whole number. One more example. If x is equal to 7 and y is equal to 0, then x into y is equal to 7 into 0 is equal to 0, and 0 is also whole number. The next property is commutative property. What is commutative property? If x and y are two whole numbers, then x into y is equal to y into x. If x and y are two whole numbers, then x into y is equal to y into x. Let's see example. If x is equal to 2 and y is equal to 9, then x into y is equal to, the value of x is 2 and value of y is 9. 2 into 9 is equal to 18. Here, y into x is equal to 9 into 2. 9 2 ja 18. We can see both are equal. That's why commutative property exists for multiplication. The third is associative property. If x, y and z are three whole numbers, then x into in bracket y into z is equal to in bracket x into y into z. Let's see example. If x is equal to 4, y is equal to 8 and z is equal to 10, then x into y into z. First of all, we will substitute the given value. The value of x is 4 into inside the bracket y is 8 and z is 10. 8 into 10. Is equal to 4 into 8 10 ja 18. 4 into 80 is equal to 320. Now, x into y into z is equal to 4 into 8 into 10. 4 8 ja 32 into 10. 32 into 10 is equal to 320. We can see the value of this one and this one is equal. So, we can say that associative property exists for multiplication. The next is distributive property. If x, y and z are three whole numbers, then x into in bracket y plus z is equal to x into y plus x into z. Let's see example. If x is equal to 5, y is equal to 3 and z is equal to 4, then we will find out value of this one. X into in bracket y plus z is equal to 5 into 3 plus 4 is equal to 5 into 7 is equal to 35. Now we will find out value of this one. X into y plus x into z is equal to 5 into 3 plus 5 into 4 is equal to 5 3 is 15 plus 5 4 is 20. 15 plus 20 is equal to 35. We can see both are equal. In other words, we can say that the multiplication of whole number is distributive over their addition. And one more thing, the multiplication of whole number is distributive over their subtraction also. Let's see. X into in bracket y minus z is equal to x into y minus x into z. If x is equal to 5, y is equal to 6 and z is equal to 4, then we will find out value of this side. 5 into 6 minus 4 is equal to 5 into 6 minus 5 into 4. 5 into 6 minus 4 is equal to 2. 5 into 2 is equal to 5 6 are 30 minus 5 4 are 20. 5 2 are 10 is equal to 30 minus 20 is equal to 10. We can see here both sides equal. That's why we can say that the multiplication of whole number is distributive over their subtraction also. The next property is existence of identity. For any whole number x, x into 1 is equal to x, 1 into x is equal to x. That is, x into 1 is equal to 1 into x. In other words, the multiplication of any whole number with 1 is the number itself. Understood? For example, x is equal to 9 and 9 is whole number. Then 9 into 1 is equal to 9. 1 into 9 is equal to 9. Therefore, 9 into 1 is equal to 1 into 9 is equal to 9. Therefore, identity element for multiplication is 1. It means if we will multiply any whole number with 1, then we will get the number itself. That's why identity element for multiplication is 1. Understood? The next property is multiplicative inverse. If x is any whole number except x is not equal to 0, then its multiplicative inverse will be 1 upon x. I repeat, for any whole number x except 0, its multiplicative inverse will be 1 upon x. So that x into 1 upon x is equal to 1. But 1 upon x is a whole number only when x is equal to 1. I repeat, 1 upon x will be multiplicative inverse of x only when the value of x will be 1. For any other whole number like 2, 3, 4, 5, so on, 1 upon x is not a whole number. How? Like if x is equal to 2, 3, 4, then 1 upon x is equal to 1 upon 2, 1 upon 3, 1 upon 4. Solving, we will get answer in decimal number. Understood? And we know that decimal number is not whole number. That's why multiplicative inverse exists only for 1. Understood? The next property is cancellation law of multiplication. If x, y and z are three non-zero whole numbers, I repeat, if x, y, z are three non-zero whole numbers, then x into y is equal to x into z. We can see here x is in both sides, so x will be cancelled out. This implies that y is equal to z. Understood? Non-zero whole numbers means whole number is not equal to 0. For example, if x is equal to 3, y is equal to b and z is equal to a, then x into y, 3 into b is equal to x into z, 3 into a. We can see here 3 and 3 is both sides. So 3 and 3 will be cancelled out. What is left? B and a. This implies that b is equal to a. I hope you have understood. Keep practice at home. Thank you.